I'm Mike Bernhardt for the Exascale Computing Project, and I'm here once again with ECP Director Doug Kothe. So welcome, Doug, on this rather chilly day in Oak Ridge, Tennessee.
It's good to be here. It's a little cold for Knoxville, but we'll take it.
Yeah, absolutely. So Doug, at the let's go back all the way back to November, which seems like ages ago.
Yeah.
We had such a crazy push to kind of bring things in at year end. We had an amazing presence at SC18 with more than 73 sessions had participants from the ECP project. I mean, it's pretty amazing. And since then, we've published 8 audio interviews with staff members talking about their research projects. And now here we are this week, fresh on the heels of the ECP third annual meeting. So I was wondering if we could start off with you maybe giving us your personal observations of that third annual meeting and just what you thought came out of it.
Yeah, Mike, it was a fantastic meeting. I'm admittedly skeptical about large meetings like this, but an ECP is a very large endeavor. It is a one opportunity once per year for all of us to come together. So in particular, we invite everybody working on ECP. So there are hundreds of people present, and this meeting was markedly better even than last year. The meeting is not a typical, it's not a workshop or a conference. We don't roll out all of our great results, and believe me, we have a lot of great results, but it's a working meeting. It's developed from the bottom up, and I need to call out Marta Garcia at Argonne and Doug Collins at Oak Ridge, who really chaired the committee, put together a great venue, a great agenda. The agenda is developed bottom up, meaning the people executing in ECP, whether it's software applications or hardware integration, propose breakouts and tutorials to address specific issues that they're having, challenges, things they need to learn, to know better. So it's basically an integration meeting with multiple projects working together. It ended up being just fantastic. Lots of great side discussions. Our DOE sponsors and the stakeholders are there, so an opportunity to check in with them. After the meeting, myself certainly, but I think most of us walk away with sort of new actions and new milestones or new things we need to tackle that I guess we hadn't appreciated before. So it's become an essential meeting for our planning and execution.
You know, one of the things that I picked up on was folks meeting face-to-face for the first time with other researchers they've been working with for 2 years.
Yeah, that's true. Certainly for early career students and postdocs, that's true. But often, senior PIs in certain fields know of each other's work, but having a chance to sit down and go through kind of, the war stories of how they've arrived at where they've arrived. I think what comes out of it is, new commitments to work together, new commitments to integrate products across ECP. That's admittedly one of our big risks, is just how are we going to integrate all these products and all these technologies and people together into some next generation seminal products. And I think it's happening, and this meeting has really turned out to be instrumental in doing that.
Yeah, to me it's become somewhat of a role model project in terms of collaboration and integration.
It has. I'm just kind of looking at some of the numbers here. I mean, we had over 100 posters were presented, dozens of tutorials and workshops. In fact, just a really energizing, uplifting meeting too. I think all of us walk away thinking we're pulling this off, we're executing, we're on track for delivering, and so it's a very uplifting meeting as well.
So, Doug, were there any surprises? Anything that you noticed where the project team missed the mark, or areas where you think changes might be needed?
Well, there are always. Look, I think we have a good handle on known unknowns, but there are always unknown unknowns. And I think in ECP, we've had a few. I feel like we're in a very good position moving into this new phase of having a rigorous performance baseline and ballistic toward our metrics. I think we have a pretty good handle on the known unknowns. I think one really, there are a number of pleasant surprises. One in particular that I see is we've got senior researchers in computer and computational science and data science who have really adapted their research plan and methodology to a milestone-based, projectized formulation. And I think they've adapted it well. I think we've struck a good balance between needing to do high-risk exploratory research and yet deliver. And so that's been a pleasant surprise for me in that these senior researchers have really bought into this methodology, and many, if not most, find it to lead to a better sense of urgency and actually more science output than a little more, say, unconstrained exploratory approach that they've adapted in the past.
Yeah, awesome. So let's jump over to the technical focus areas quickly and just kind of give our followers a brief glimpse of what you think is going on there. And let's start off with AD, the Application Development Group, led by Andrew Siegel from Argonne and Eric Drager from Livermore. Powerful combination there in terms of leadership. What would you call out to the followers as a few of the highlights that you see?
Boy, it is hard to run through the highlights. I'm just this is frankly maybe shouldn't be a surprise, but our teams have been executing now for about 2.5 years, funded and up and running. And when I say our teams, across ECP, there are, I think, 103 research teams. And so Applications has almost 40 research teams. And so in looking at the highlights that have come in the last 6 months, it's just been astounding. I guess I'll start with Andrew and his team performed a fairly rigorous assessment of the projects, brought in external reviewers, and have documented the results of that assessment. And that's very important for us to understand how the projects are doing. Are they on schedule? Are they on track? And if not, what corrective actions can we implement? The plan is for that a public version of that report to be available probably next month, and I think the community I'd be surprised if they didn't really enjoy taking a look at the breadth and depth of what we're going after. Just to kind of run through, and I'm going to look at a few notes here, but run through some examples. And again, I'll just note that this assessment report will give a lot more detail. Our co-design efforts have been really delivering. We have 6 in various stages of maturation. And so the co-design efforts are focused on computational motifs, common patterns of communication and computation, and they're really delivering. The AMRX Co-Design Center, led by John Bell at Berkeley, is really impacting 5 different codes, probably will impact many more moving down the road, releasing new technologies for tiling on node performance, for embedded boundaries, for pushing particles. We're seeing a lot of great results coming out of applications using that technology. The SEED Co-Design Center, which is structured around, it's unstructured meshes and PDA-based solvers for finite elements, is also impacting a number of applications. We have a Particle Co-Design Center, COPA, an online data analysis and reduction center known as CODAR. All these centers are pushing out their technologies and directly impacting applications. So our model for co-design for apps, which is to focus on these motifs and cross-cut, hit multiple apps, is really paying off. And I also need to point out the Exalearn Co-Design Center, which is a new, it's 4 months in. They've got a really good plan in place and a very aggressive plan for how to impact a number of applications. But if I can, Mike, maybe give you a few examples on the application side.
Yeah, that'd be great.
So just a couple to highlight. The small modular reactor application known as ExaSMR has demonstrated recently almost a 40x speed up on Summit and 20x speed up overall by refactoring their Monte Carlo algorithm from history-based to event-based. And by going to event-based, they're able to really, really very effectively utilize GPUs such as the NVIDIA Volta on Summit. So that's been, basically 4 or 5x algorithmic improvement over the hardware improvement. So that's the kind of thing we are after in ECP. We're not just going to exploit the hardware. We absolutely need to do that, but we anticipate and are planning for algorithmic improvements. And so this is a good example of both. The NW Chem EX chemistry application has really reduced its memory footprint and communication footprint for Cholesky-based decomposition of 2-electron integrals. That's a key kernel for electronic structure chemistry codes. The games application is now interfaced with quantum Monte Carlo. That's a big step forward. They're doing performance analysis and scaling up, which they need to do, and we're seeing some good returns there. The accelerated molecular dynamics application known as Exalt, and that's led by Art Voder out of Los Alamos, has demonstrated the ability to scale up to 272,000 cores, and before they could not scale well at all, and that's been working closely with some software technology efforts such as the Slate effort led by Jack Dongera, and they're being able to exploit very efficient application of DGEMS, sort of a core BLAS kernel. We've seen QMC Pack, which is a quantum Monte Carlo material science application, is showing a 6 to 7x speed up by delaying their updates in terms of their Monte Carlo walkers. Again, another algorithmic improvement.
Yep.
And so it's the thing to emphasize with our applications is, obviously the first order is to anticipate, prepare for the coming hardware and be ready to utilize it. But in doing that, rethink the algorithms. And in every case I can think of with our applications, they have unique plans to rethink the algorithms, to refactor, redesign, and exploit the hardware technologies. And here is where intimate integration with the software technologies, making sure that application needs and requirements flow down, but also new capabilities in the software really impact where the applications go. So it's very much a codependent arrangement. There's just dozens of more examples. Again, I'll just point folks to this assessment report that will come out that ought to give people a lot more nuggets and a lot more threads to pull with regard to the details of what our apps are doing.
Sure, and we're looking forward to it, and we'll get that a lot of exposure.
Yes, we're anticipating this will lead to a lot of new, or at least potential new interactions and collaborations.
So let's move over to software technology. We refer to it as ST, led by Mike Rue from Sandia and Jonathan Carter from Berkeley.
Yeah. So Mike and his team have been together now for over a year and really moved ST from big R, little d, research and development, to more development and deployment. And they've gone through already 2 releases of their SDKs. And the initial software development kit, initial focus is on a math SDK. And I think I spoke last time about this, but of the 90 or so products in ST, tangible software products that we're working on, and we don't necessarily own them all, we're contributing to a lot of community products. We're packaging them up to a half dozen or so SDKs around common themes. And the math SDK is a good example where you have linear and nonlinear, dense and sparse solvers, eigensolvers, etc., that are being packaged together. And so Mike and his team last November had the first release of our SDKs, principally the math SDK. I think he had something like 25 ST products in that one release. And that's at e4s.io. The latest release, which was in December, I think now we're up to 37 products. And so Mike and his team are really adopting a very agile methodology, which is frequent releases. So I'd encourage folks to check out e4s.io and kind of see what the products are rolling out. Also note that just like Andrew and the AD team, Mike and his team are releasing a fairly regular capability assessment report, or CAR report as he calls it. The first one he released last year, and he's got another plan released of this report, which is an update on all the activities and products in ST. I think he plans for that also next month. So he is planning for another public release of his report that'll give folks a better understanding of just what he's doing, what he's planning to do. In terms of just to call out a couple of examples of ST efforts, OpenMP has really worked hard on deep copy and memory management APIs for heterogeneous architectures. There's been some great improvements there. ECP is playing a major role in the low-level virtual machine, or LLVM as we call it, and a lot of work in making sure that OpenMP works well there, and evolving the compiler and making sure that we have C++, C, and Fortran front end, so that we're playing a major role there. Mike does point this out as doesn't necessarily lead to products, but it's a key area for ST, and that's to participate in community standards. And so ST staff sit on a number of standards committees, and we think, well, this is really important and instrumental. Examples being we sit on MPI, OpenMP, C++, OpenACC, Fortran, LLVM, the list goes on, and this is itemized or laid out in his CAR report. The point being, we can use, let's use extractions like Cocos and Raja at Sandios and Livermore respectively. These abstraction layers are really proven instrumental for shielding where appropriate from applications, the compute and memory hierarchy in our architectures. Those abstractions, we believe, can and should lead to next generation or future standards, and we're playing a role there. We think that's very, very important. Again, folks should look at the CAR report, and I think they would understand, hopefully be impressed with the breadth and depth of work we're executing.
That's awesome. So moves us over to hardware and integration. We call it HI, and that's led by Terry Quinn from Livermore and Susan Coughlin from Argonne. It is an area that's wrapped up in a lot of NDAs, non-disclosure agreements.
Right.
But what can you tell us about some of the efforts that are going on there that are available to talk to the public about?
Sure. So that this focus area has been up and running now. It was a new one a year ago last fall, and so for a little over a year, it's really gone through startup. It's kind of up in steady state, fully running. So hardware and integration is kind of a broad and loaded term, but it includes several key areas. One is our path forward, and that's funding U.S. vendor R&D for node and system architecture designs. And so there's where some of the non-disclosure agreements are necessary to get into details. But basically, that program has been executing since 2016, and the vendors are delivering some fantastic results. And we're confident and are seeing some of these technologies are going to appear in the Exascale systems. We're probably about a year and a half from seeing that program wrap up, and so it is very mature. And I'll just note at our annual meeting, the vendors are there, the U.S. HPC vendors are there, and they present their latest progress. These are milestone-based contracts, and so we're really doing our diligence in terms of making sure that their plans are executed and they deliver, and we're really seeing that program. We're really seeing the program bear fruit and lead to some what we believe are going to be some exciting systems at Exascale. But to mention kind of a few newer areas that are really delivering in Terry's, what we call HI. We have a continuous integration activity, and here's where, you mentioned earlier, where were some of the surprises. One I forgot to mention is the fact that we really need to resource load and plan and execute the integration of our products with facilities. This is a formal handshake between Mike Haru's ST products and SDK products with the facilities. So Terry's effort, led by Dave Montoya at Los Alamos, the continuous integration effort, is to push these SDKs out, continuously integrate them, test them on our DOE HPC facilities with an eye toward kind of the 6 labs that have been really leaders in their facilities. And we're doing that now. We're pushing the SDKs out. We're starting to test the SDKs on the facilities, and we anticipate that evolving to where users will get on HPC facilities, say the Oak Ridge Leadership Facility here at Oak Ridge, whether it be the Titan or Summit system, and they'll see alpha and beta versions of our products there sooner rather than later. So that's a key aspect. Another area that I'll briefly mention is application integration. And so we have our application area, but it's important in the hardware integration area to make sure that the applications are deployed and up and running on the systems, and our facility computer and computational scientists are helping to performance tune and take that sort of final step across the finish line. And so we've got 3 teams now that are targeting specific applications at in ECP, sitting at NERSC, the Argonne Leadership Computing Facility, and the Oak Ridge Leadership Computing Facility, who are targeting very specific applications. So this is, again, a formal handshake between the applications team and the application specialist at the facility. So there's been a lot of progress there, and we're looking forward in the next in the years to come. Terry's group is going to really take our products across the finish line, deliver on the metrics that we promised to our DOE sponsors in ECP.
Got it. Awesome. So we've got this multi-lab, widespread, very complex structure put in place. It requires a rather sophisticated project management function, a project office, to kind of support the 3 technical focus areas and just kind of keep everything on track. Can you just give us a glimpse, maybe a little bit of an insight into how the project office is evolving in order to keep this project moving forward and maintain this momentum.
Yeah, it's a good question, and it's an aspect of ECP that's critical to our success. It's an enabler, and yet we don't talk about it as much as we should. You know, we're always it's always very exciting to talk about the science and the products we deliver, but the project management aspect is really what makes it happen. So Kathleen Baldwin here at Oak Ridge leads that effort, and her team is now staffed up, I think, fully to support these 3 technical focus areas. I'll just say a couple of comments there. We view the project management aspect of ECP as of course essential, but also this isn't a customer-client relationship. It's not a support role. It really is a peer relationship where our PhD scientists really need to work hand in hand with our project management. And what we see is a good cross-fertilization. Our scientists are learning various aspects of project management that not only are critical for ECP, but they can carry forward to their next endeavor and really execute, we think, in a more efficient way. But the project management team has really been learning the aspects of the science and trying to understand how they need to tailor sort of textbook project management to research. And there are changes that are required to adopt higher risk, exploratory, higher return, agile development. And so the project management office led by Kathleen has done a really good job in tailoring, the textbook approach to this very unique situation. So, bottom line is they're not nice to have, they're critical to ECP's success. The project office is really doing a great job in working with our technical teams in delivery.
So it's sophisticated processes, management tools, staying at the cutting edge, and strong project management expertise all coming together.
Indeed. I think there's many requirements here, but one key requirement that is really bearing fruit is everybody working on ECP needs to be on the same page, see the same plan, and be able to interact with that plan in what I'll call a project management database. And we've been able to pull that off, adopting some commercial tools for agile project management where, in principle, everybody working on ECP can see the entire plan, and that's important for integrations. The project office has really done that, implemented those tools and approaches very well, and it's become very crucial for our success.
ECP's very fortunate, step back and look at this, to have such a strong, dedicated, and experienced leadership team throughout, from the focus areas to the home office to the project office and so forth. And now, you've got your deputy director, our new deputy director, Lori Dyson, up and running and working with you at the bridge of the ship to keep us moving forward.
Yeah, she's been a breath of fresh air. She's come in and basically saluted and said, "I'll do whatever I need to do to help you guys." And she's done that. We've given her some of our more difficult tasks that require her experience in technical leadership. But she's also rolled up her sleeves and said, "Whatever I need to do, I will do." And challenged us on some areas where she wonders, why are we doing this? Can we do it better? Can we do it differently? She's just been a real joy to work with. She's her reputation preceded her, and we're not surprised at all. She's just been a crucial member of the team. We're really, really lucky to have her.
That's awesome, and we'll be hearing a lot more from Lori as we move forward.
Indeed. I think she has a lot of good things to say, and obviously has already done a lot of good things for us.
You bet.
So.
Doug, thank you. It's a great update. I think we're wrapped up, unless you have anything else you'd like to say.
Just thanks for the time. It's an exciting endeavor, and we're really feeling very good about where we are right now. So
awesome.
look forward to letting the community know what we're up to in the future.
Good deal. We've been chatting with ECP Director Doug Kothe for the Exascale Computing Project. I'm Mike Bernhardt.